Hello, welcome to RVB Education. In this video lesson, we are going to find support reactions of beam subjected to point loads by graphical method and analytical equations. This is a problem statement. We have a simply supported beam subjected to 3-point loads. To begin our graphical solution, we first construct a space diagram to a linear scale 1 centimeter is equal to 0.5 meter. The step-by-step drawing construction is illustrated here for your reference. You can follow these exact steps. We use Bose notation to label the spaces between the forces. This is P, Q, R, S, T. Next, we construct the vector diagram using a force scale where 1 centimeter is equal to 10 kilonewton. We draw a vertical line representing our loads PQ for 40 kilonewton, QR for 30 kilonewton, and RS for 80 kilonewton. After drawing the total load line, we select a convenient point O outside the line, known as a pole, and connect it with a points P, Q, R, S. And this is a polar rays. Now back to space diagram. We project the line of action of all forces downwards from our space diagram. Inside a space P, we draw a line segment OP parallel to OP polar ray. We continue this across each space, drawing OQ, OR, and OS parallel to their respective polar rays to form a funicular polygon. Finally, we close the polygon by drawing the dashed closing line OT. Using a roller scale, we transfer the orientation of this dashed closing line OT back to our vector diagram. We draw a line parallel to OT starting from our pole O until it intersects our vertical load line. The intersection point is labeled as T. Now, zooming to the vector diagram, point T splits our total vertical line into two segments, which represent our two support reactions, Ra and Rb. To find the magnitude of the reactions, we measure the lengths on a vector diagram and multiply by scale. The length Pt corresponding to reaction Ra measures 6.2 centimeter. The length St corresponding to reaction Rb measures 8.9 centimeter. By doing this calculation, we get the final answers as Ra is equal to 62 kilonewton and Rb is equal to 89 kilonewton. To verify our graphical results, we use analytical equilibrium method. The full step-by-step calculations is shown here. You can pause the video here to look over these steps in detail. The result analysis. The support reactions of simply supported beam were determined using both graphical and analytical method. A comparison of two methods shown percentage error of 3.33% for reaction force at A and 1.11% for RB. The difference arises mainly from the drawing inaccuracies, scaling limitations, and measurement errors inherent in graphical techniques. Since the percentage errors are small, the graphical results can be considered acceptable and in good agreement with the analytical calculations. At last, take this problem for a practice and drop your answers in the comment box. I hope this video lesson helped you to understand the concept. Subscribe to my channel for more lessons. Thank you.